So there are 4 project areas within the Fairness, Transparency, and Accountability Research Initiative at PAI. First off, we have Algorithmic Fairness, and then Explainability, Diversity and Inclusion, and Criminal Justice. So the motivation for our Fairness, Transparency, and Accountability work at PAI is that this is an area where there's been a lot of desire for action, but there's still very unclear solutions and best practices for what folks should actually do to address these abstract concepts of fairness, transparency, and accountability. And so our theory of change is that by leveraging PAI's unique position at the intersection of industry, civil society, and academia, we can both map and tackle some of these challenging research questions that are facing our partner community, and we can also share learnings from across our community and work towards developing best practices. And for us, this means doing a combination of research, white papers, and convenings. The first area within fairness, transparency, and accountability, of course, is algorithmic fairness. And our work within PAI in this space really concentrates at the intersection of algorithmic fairness, demographic data, and the law. So the problem we're really trying to address here is, despite growing calls for organizations to address algorithmic bias, in practice, they often face barriers when it comes to trying to measure and mitigate bias in practice. And some of the work that we've done at PAI suggests that there are specifically legal, reputational, and technical barriers when it comes to using demographic data in service of fairness goals. And in practice, this often prevents wider spread action around algorithmic bias issues. So our work in this area comes in 2 stages. First off, we're working to map the current barriers facing organizations. And this comes within 2 lines of work. One that focuses on the legal compatibility of bias mitigation techniques, and another that focuses on demographic data and its use in bias detection. And then the second stage is, once we have mapped out these current barriers, we'll be working towards a multi-stakeholder process to try to generate recommendations for how to address these issues. So first off, the area of work around legal compatibility of bias mitigation involves questions of how do we ensure that bias mitigation strategies are compatible with the law? And so why is this important? Why do we care about legal compatibility? It's important if we actually want to prevent the proliferation of biased algorithms in practice. If we want to, for example, demonstrate evidence of algorithmic bias and ensure that this evidence has teeth to it, then it must be accepted by what judges, juries, or regulators would consider to be evidence of discrimination. Similarly, if we actually want to mitigate bias, then the techniques that we use cannot be considered discriminatory in and of themselves. And so our work in this space first started with a project looking at the legal compatibility of fairness definitions, whereby we took several terms that are commonly used in the machine learning fairness literature that are actually legal terms. And we mapped these out and found that there are significant divergences between how the machine learning and legal communities are approaching fairness. And this is work that we presented at the HCML workshop at NeurIPS last year. In addition, we've looked at the tensions specifically around using protected class variables. So these are variables like race, disability, religion that are protected under U.S. anti-discrimination law. And the reason that there's a tension here is, on the one hand, we have a technical need to use these sorts of variables if we want to detect and mitigate bias. The intuition being that if we actually want to actively address disparities across different groups, as evidenced through various data or algorithms, then we actually need to take into account what groups people are in and then try to actively reverse these biased trends. And also, removing these variables from data does very little to actually prevent bias due to what's called omitted variable bias. So then why is there a tension around this? There's a tension because the law, on the other hand, has a very strong preference for decision-making that is blind to protected attributes. And in fact, some proposed regulations look to the presence or absence of these variables as evidence of algorithmic bias. So for example, late last year, the U.S. Department of Housing and Urban Development proposed a rule around disparate impact liability, which is a form of anti-discrimination liability, whereby there would be a safe harbor for algorithms that do not make use of protected class variables or close proxies. So why do we need to resolve this tension? Why does it matter that there's this disconnect between, on the one hand, a technical necessity to use these variables, and on the other hand, the law's desire for blindness around these variables? This is important because the law might inadvertently prohibit the use of bias mitigation techniques. And even if the law does not prohibit these techniques, legal uncertainty in this space might drive organizations towards inaction around algorithmic bias as what might be perceived to be the safest solution. So then what can well-meaning algorithm developers do to address algorithmic bias in their models in a legal way? So that's the topic of two of our papers in this space. One is reconciling legal and technical approaches to algorithmic bias, which is forthcoming in the Tennessee Law Review and We Robot Conference. And this discusses the importance of distinguishing between different use cases of protected class variables. So are you using these variables to increase the salience of this protected attribute or decrease it? Are you trying to debias your model or bias your model? And this paper also specifically proposes causality and causal inference as a unifying concept in both the machine learning and legal contexts that can help draw these distinctions between different use cases of protected attributes. In addition, we have a paper forthcoming called Affirmative Algorithms, the Legal Grounds for Fairness as Awareness, and this examines the extent to which algorithmic fairness techniques might be interpreted from a legal perspective as being forms of affirmative action, and how jurisprudence from the higher education context might create some roadblocks towards actually mitigating bias in practice. And this paper proposes a path forward looking through the strong basis in evidence standard that is used in government contracting cases. So those were some of the projects that we've worked on in the legal compatibility realm. The other aspect of algorithmic fairness we focused on is this idea of demographic data and bias detection. So our work here started with a convening we hosted earlier this year, co-located with the FATSTAR convention. And this was a closed-door convening where we brought together academic and industry experts from both the legal and machine learning communities to talk about how demographic data should be used ideally in terms of fairness goals, or should not be used, I should say. And the discussion surfaced a lot of really key themes, in particular around legal uncertainty, reputational risks, privacy concerns, and definitional issues in terms of what counts versus doesn't count as demographic data. And so we have some takeaways that we've published as a white paper that you can find at the link below. But we've also built upon the insights from that convening with an interview project. So the goal of this project was to more specifically map out these legal, reputational, and technical challenges that folks are experiencing in practice. And our goal at the end of the day is to enable organizations to take more action to address algorithmic bias by mapping out what are the challenges that they are experiencing, and then using that as a basis for our multi-stakeholder work in terms of generating best practices and recommendations. Explainability is also a core area within our Fairness, Transparency, and Accountability Research Initiative, specifically related to both the transparency and accountability prongs. So our work in this space is motivated by the idea that many have seen explainable machine learning as a potential way of opening up the black box of machine learning algorithms and thus enabling explanations that can provide more transparency for various stakeholders and also create feedback loops around accountability. Our work in this space, however, has suggested that current techniques don't necessarily adequately enable practitioners to provide explanations to a wide variety of stakeholders. And so our work in this space has taken on a few stages. First, we worked to map out what the current practice is. Next, we are in the process of reviewing relevant literature in this space. And then we'll be working with partners on developing a framework for tailoring explanations for specific stakeholders and contexts. So to that first stage, we conducted an interview-based project last year where we interviewed over 20 organizations to see how they were using explainability techniques in deployment. And one of the major findings from this paper was that in practice, explainability is often used by internal stakeholders such as machine learning developers in order to debug their models rather than being presented externally to provide greater transparency for end users. And our paper mapped out some of the reasons for this. And so we presented this both at the FATSTAR 2020 conference and also at the HTML workshop at NERPS 2019. So given that gap that we saw based on that initial project, this gap between the goals of explainability towards transparency and accountability and the practice, which is a little bit more oriented towards model development, we organized a convening which we called Explainable AI Day, where we brought together a wide variety of stakeholders, including explainability researchers, practitioners, policymakers, and civil society organizations, with the goal of identifying what are the problems where explainability might be able to offer interesting and helpful solutions, what are the relevant stakeholders, and what are the gaps in terms of what we would need to see from research or implementation in order for explainability to reach these goals. And based on this convening, we put out a paper that summarized a lot of the insights that we gained and that we then presented at a few workshops. Ongoing work in this space includes a project where we were working with a variety of partners to put together an interdisciplinary literature review about the role of uncertainty as explanation. So given that a key part of machine learning algorithms is the uncertainty implicit in them, how do we go about uncertainty communication, quantification, and communication in a way that can enable greater transparency? In addition, as I mentioned earlier, we are working to develop a framework for how to tailor explanations to the specific needs of particular contexts and stakeholders. So that is a project that we are currently scoping, and we'll be working closely with partners to build out those recommendations and that framework. Diversity and inclusion is an extremely key aspect of our work within fairness, transparency, and accountability to ensure greater equity and social justice within the field of AI. The problem that we see in this space that we are trying to address through our work is that the field of AI still suffers significantly from various D&I challenges. And although we're seeing a lot of organizations invest in various D&I initiatives, there's still a lack of clarity around what works and what doesn't work, and especially what some of the unique cultural factors might be within the field of AI. As a result of this, we'll be launching a research project very soon in fall 2020 to examine a few key questions, including what cultural factors affect inclusivity in AI workforces, what organizations can do to address issues of attrition of women, minorities, or others due to these inclusivity concerns, and then finally, what are some best practices for D&I initiatives. Criminal justice is the first area that our fairness, transparency, and accountability work started on at PAI, and it continues to be an area of really deep research and insights for us. So our criminal justice report was our first PAI research output and multi-stakeholder project. And in this report, we examined the use of risk assessment tools in the pretrial context within the United States. And we chose the criminal justice as the focal point for this initial report, since this is arguably the highest stakes context where machine learning is being deployed. And we wanted to highlight the importance of these fairness, transparency, and accountability issues. So this report seeks to represent the viewpoint of the partnership in establishing 10 minimum requirements for the responsible deployment of these sorts of tools. But the conclusion of our report was that no tool currently meets all 10 of these requirements. So following on to that work, we also did research specifically relevant to the current pandemic and the use of the pattern risk assessment tool by the Bureau of Prisons to start determining who should be prioritized for release from prison into home confinement. And our research in this space highlighted the potential for pattern to amplify existing racial disparities, and also how pattern was not trained to account for a pandemic environment and not trained to account for different trade-offs with health risks that are especially relevant when making these sorts of sensitive decisions. And finally, ongoing work in this space includes research specifically on statistical methods for measuring and mitigating algorithmic bias in arrest data. So we're looking at how can we use multiple sources of data, particularly data on both victimization and arrest, to get a better sense of various sources of bias within these data sets. And also we're doing continued research in the risk assessment space to examine how different sorts of interventions that have been proposed can or cannot reduce bias in these tools. So thank you all so much for joining today, and a special thanks in particular to all of the partners who contributed their insights and expertise to all of this work, and also to all of our wonderful colleagues without whom none of this would have been possible. So thank you all so much for joining us.